Okay. Then first of all, I would like to welcome you all for this day school CYU 4301. Actually, I hope to discuss electrochemistry part under the unit 3. And this is the compulsory day school. And as you all know that you have the CAT exam for this unit when? During the second CAT, not the first CAT. So you have more than enough time to study the unit 3. And I hope to discuss at least 2 sessions today as an initiation and to encourage you to study this book. It is a very large book. I think we have to encourage you to go through the book. That's why we decided to do this compulsory day school, starting with the first 2 sessions. Okay, then this should be an interactive session. I hope you will all join with me and answer the questions. First, we'll move to the session 1. What is electrolysis? Can anyone say what is electrolysis? You have already studied galvanic cell under the level 3 theory part as well as practical. Then what do you mean by electrolysis?
Dissociation of a solution.
Dissociation. As a result of what? What is galvanic cell? First say about the galvanic cell. What do you mean by galvanic cell? What happens? You have to talk, කතා කරන්න. Galvanic cell. What do you mean by galvanic cell? What is happening there?
Using the chemical reactions, we are producing electricity.
Yeah. Then in electrolysis,
using the electricity, we are initiating chemical reactions.
Yeah, that is correct. The dissociation is that is correct. Dissociation is somewhat okay, but as a result of the external energy source, electricity. Then chemical reaction is driven by an external source of electricity in electrolysis. Then consider this cell. We have a battery here. Then can anyone say what is anode and what is cathode? You have A and B 2 terminals. I am asking what is anode? First anode.
B.
B. Why?
B.
Positive terminal.
Yeah, that is correct. Anode is positive terminal, and at the anode, what happens? What is the reaction? Oxidation. At the cathode? Reduction. Then let's assume we have fused potassium chloride. Then we have potassium plus ions. Then it goes towards the negative terminal. And the chloride ions moves towards the positive terminal. Then what is happening? What can be the cathode reaction and what can be the anode reaction? You can see the book can say it doesn't matter. Just go through the book is more than
Cl minus will be oxidized into Cl 2 plus
Reduce chlorine.
Yeah. And potassium? Likewise.
Reduces to potassium.
Yeah. Then here I want to mention that one while you are writing the chemical equations, especially for the electrochemical cells, you have to write down the physical states. For the level 3 as well, if the physical states are not there, we are not giving any mark for that equations. We remember that one. Then you can see oxidation and the reduction reaction. Now you have little bit idea about what is electrolysis, what is positive terminal, what is negative terminal, and what is happening at the anode and what is happening at the cathode. Then let's see, movement of ion is equal to the electric current that passes through the wire connecting the electrodes to the battery. Here you know normally we are passing current through a metal. Here what we have solution. Then do we have electrons inside the solution? Do you have electrons? Metal now you can see electrons in the metal. If you have a metal, you can see electrons. You can see you have electrons. But in the solution, what we have?
Solutes.
What are the, what? sorry.
Ion.
Ions.
Yeah, ions are there. Then ions are moving. Once you supply the charge, then what happens? Positive ions moves towards the negative terminal and chloride Cl minus moves to the positive terminal. Then can anyone say where to where the electric field? Usually, electric field where to where? A to
Cathode
B
to
or
anode.
B? A to B or B to A?
A to B.
A to B. Correct? I am asking electric
B to A.
field. B to A. Electrons are other way around. Electric field
Okay, got
is
it.
B to A. Then positive ions are pushed around the direction of the electric field. Then you can see how it happens. The positive ions push along the direction with the electric field. Got it? As it is going from B to A, positive terminal electric field from positive to negative. Then you can see positive ion push along the direction of the electric field. Then negative ions, what happens? Opposite to that direction. Now, is it clear up to now?
Yes, madam.
Yes, madam.
Then we will move to the activity 1. It is based on the 1.1 question number 4. Can anyone read the question? Can anyone read the question? You have your course material and I am asking to read the activity 1.1 question number 4.
Madam, we don't have our course materials.
You do not have course material. I also do not have course material at the moment. Oh, it's okay. Is there anyone with the course material? At least repeat, student.
Yes, madam, I have.
Then can you read it?
Okay, consider the galvanic cell represented by AS A2 plus aqueous, B3 plus aqueous, B solid. The positive terminal is A solid. Explain the process that create an electric current within the cell when an electric current is drawn from it.
Okay. Then you have to consider this galvanic cell and the positive terminal is A. Then they ask explain the process that create an electric current within the cell when the electric current is drawn from it. Can anyone explain? Positive terminal is A. You have a galvanic cell. Here not a electrolysis is not same. Galvanic cell is there. Positive terminal and the negative terminal and positive terminal is A. Explain process that create electric current within the cell when them. This is about the galvanic cell. Then in electrolysis, what happens? Opposite to this one. Do you know that one? Galvanic cell, what is positive terminal? Cathode. Then electrolysis, it is opposite to the. If you compare the galvanic cell and the electrolysis, what happens? Galvanic cell, cathode is positive terminal, electrolysis, anode is positive terminal. Then there you have a galvanic cell and positive terminal is A. Explain if you supply electric current, what happens in this cell? Just think. Can you explain that part?
B undergoes oxidation and A undergoes reduction.
Yeah, that is correct. The reduction, here this is for the galvanic cell, this one, and for the electrolysis, it is opposite to that one. Then B, oxidation.
Yeah, that's right. අපිට PDF එවන්න ඕනේ. PDF එක දාලා නැහැ. PDF එක බලලා ඉගෙන ගන්න. මම PDF එක හම්බුණා.
Okay. Then once you got the book, you can get an idea. Now I think it is clear what is the difference between galvanic cell and the electrolysis. Then we will see how to write the answer for that question. Then B is oxidized and A reduced. That is correct. You ask. Then what is happening inside the solution? You have A plus ions moves towards the negative terminal. Here, once you set it, this is negative and this is positive. We connected the two cells using a battery. Then you can see this is negative terminal as this is negative part and the positive sign is here. Then this is positive. Then oxidation and the reduction you can identify easily. By looking at this, you can say which ions moves towards the positive. Always positive ions moves towards the negative terminal and ions of them moves towards the positive terminal. And also if you have a solution, water is there, then H plus moves towards the negative terminal and OH minus moves towards the positive terminal. This is simply what is happening once you connect it. Then we will move to the next one. I think it is clear. Then we will see what is electric charge. What do you mean by charge? Q. SI unit of the charge is coulomb. You have already know that one. SI unit for the charge is coulomb. Then what is the charge of the electron? For A levels, you memorize during your A levels, you memorize
Minus
this
1.
Minus 1 means that charge minus 1. No, I am asking the charge of the electron.
Minus 1.66.
Yeah. Minus 1 is usually we are saying it is minus 1 because we are converting it. Then in coulomb it is this much of charge. Then total charge is the sum of charges of the components. Then if you want to get the charge, then you have to consider the charge and get the sum of them. We'll discuss with the question activity. And the charge per mole. What do you mean by charge per mole? How to get that one? You have to multiply the charge by the Avogadro number. Then I am going to introduce the Faraday constant here. Charge by the Avogadro number. Then charge is represented by E and now Avogadro number is represented by Na. By multiplying both E and Na, you will end up with this one. You have already used this Faraday constant several times in your level 3, even in A levels. Then this is the way how to get the constant. The charge per mole. Faraday constant is coulomb. Charge per mole. Moulate ආරෝපණ ප්‍රමාණය. How we are getting that one? Charge per mole is equal to charge multiplied by the Avogadro number, and it is E is the constant, Na is the constant, then Faraday constant is like this. Then you know how it comes, the Faraday constant. Then approximately we are getting this one. This is the original value. While you are substituting the values for your exams, see what is the Faraday constant given in your paper. Usually we are giving 96,500 coulomb per mole. Then charge number Z. It is the charge the number of protonic charges on an ion. If you have magnesium
2.
2 plus, magnesium 2 plus, Then the charge is 2. Then you know what is the charge number. Then the charge on 1 mole of iron of charge number Z is given by. Then you know number of protonic charges, how many here? 2.
2.
Then if you want the charge on 1 mole of iron's charge number Z is given by how? How much then? Q is
Into-
equal to NaEZ. Why? NaE is the charge of Faraday constant. You have to multiply by the Z. Charge number is here. For 1 it is N. For here, charge per mole, per 1 mole it is ENA. Now we need what? Is for a Z. Then we have to multiply it by Z. Then you have Q is equal to NaEZ. Then you do not need to memorize them all, but just keep a certain idea how it comes. Then it will be easy to understand. That is the reason I am explaining everything. Okay, then charge on N mole of ions, you will end up with this one. You have to multiply it for N moles. Then this is the equation you need to memorize. Q is equal to NFZ. Then you should know how it comes. That is the reason to explain everything. If you know everything, it is easy to understand. Then we remember Q is equal to NFZ. This is the only thing you need to memorize from here. Then we'll move to the next one. Activity 2, 1.23. This is very easy. You have aluminium 3 plus 1.5 moles. Then ask in Q. Can you find out what is Q is equal to NFZ? Can anyone say how to get the answer?
1.5 into 96,500 into 1.02.
While you are saying the answers, please say the units as well. 1.5 for mole by Faraday constant 96,500 coulomb per mole
Into 6.022 in mole
minus into Z is what? Aluminium. Protonic charge 3. Then this is the answer for this question. I think you got the. Okay. Then next one is the electric potential difference V. Potential difference. SI unit is volt. What is the meter that you can use to measure this potential difference?
potential
Sorry?
voltmeter.
Correct. Then the electric potential difference is the electric work done is 1 joule when a charge of 1 coulomb is taken from point A to point B. This is the definition. Then it means 1 volt is equal to work done. Work done in joule per coulomb. 1 mole. You have A and B. And let's assume it gets from A to B 1 mole of charge. 1 coulomb charge. Sorry, not 1 coulomb. From A to B, it travel 1 coulomb. 1 coulomb. Then the work done in the system is called as when it means for a work done in the system in joules per coulomb is given as volt. What you should know, this volt is SI unit, but it also equal to joule per coulomb. This is very important because if you have the electric potential, then you should know how to convert it into joule and per coulomb. Then this is the relationship. Actually, V is equal to JC minus 1. Then you need to memorize this unit as well. It means work done in joules per coulomb, per 1 coulomb. Then as a relationship, potential difference is equal to work done over charge. Then it is easy to memorize, ne? Sorry. Work done over charge. It means J over C. Work done we are measuring from joule, charge coulomb, JC, J over C. Then electric field strength taker. What does it mean? I am just introducing the terms in your book. Then electric potential difference per unit length. Potential difference per unit length is the field strength. Potential difference per unit length. With the name strength, we are talking about a strength. Potential difference for unit length. Then it is E is equal to V over L. V is the potential difference, L is the length. Then the SI unit, what can be the SI unit? Can you tell me?
Volt per meter.
Volt per meter. SI unit, we are not saying, if it is volt per centimeter, is it a SI unit?
No.
If you are measuring the length in centimeter, then is this a SI unit?
No.
Yes
No,
or
madam.
no? Okay.
No.
Well, I just want to ask it. Sometimes some students got it mistakenly. Then the force of F on a charge Q placed in an electric field of strength E is given by, force is given by F is equal to QE. Q is the charge, E is the electric field strength. Then now you have certain relationships. E is equal to VOL, force is equal to QE. Then some equations are given in your paper, but some equations you need to memorize. Just try to understand the wordings, then it is easy to memorize it. The force charge placed in an electric field of the strength is given by F is equal to QE. Then electric current. What is current? Electric current is the rate of flow of positive charge. Rate of flow of what? Positive charge. Then current, positive charge, rate. We are talking about the rate. You know, if it is a rate, we have to measure the time. Then I is equal to Q over delta T. It means this is the charge. The charge flow through a system with the unit time is with the given time. Then to get the rate, we know if you want to get something, we have to get anything. If you want to talk about the rate, what you have to do, we have to get the measurement of change of any quantity, you have to divide by the the time taken to happen that change. මොකක් හරි change එකක් වෙන්න ගිය කාලයෙන් බෙදුවා නම් we can get the rate. Similar to that one, the electric current is the charge, positive charge, rate flow of positive charge. It means Q over delta T, change of charge with the given time. Then you need to memorize this one. So usually Q is equal to, you are memorizing this as Q is equal to I delta T. Some students memorize like this. It doesn't matter. However, you need to know what is there. If you know the definition, it is easy to memorize it. Okay, then the current is the rate of flow of positive charge. Then it is Q over delta T. Then what is the SI unit for the current? SI unit for the current?
Ampere.
Ampere. If you consider this equation, it is similar to what?
Coulomb per second.
Coulomb per second.
Coulomb.
Then direction is also always which direction? Flow of positive charge. You know the current is equal to the direction of the flow of positive charge. If you have this kind of thing, then you have positive terminal and the negative, they called high voltage and here low. Then always it moves from positive terminal to negative, positive direction to negative. The final effect of this flow of electrons is equal to the flow of positive charges in the opposite direction. If the current goes from positive to negative, the electrons goes from negative to positive, opposite to that one. Then magnitude is same, but the direction is opposite. Then we'll talk about the metallic and ionic conductors. Can anyone say metallic conductor? You know the copper, zinc, all are metallic conductors. Those
Which
are
have
metals.
unpaired electron.
Yeah. Then, if you have metal, if you have a metal, it is a metallic conductor. What we have electrons. We can see
Unpaired.
electrons there. Then what happens? Electrons are moving from negative to positive, and the current is opposite to that one. This is the way what is happening in a metallic conductor. If you have an ionic conductor, what is happening here? Ionic conductor, we have ions there, then positive ions, as I mentioned earlier, moves towards the negative direction, and negative ions moves towards the positive direction, and we can see a current from positive terminal to negative terminal similar to the metal conductor. The only difference is in metallic conductor, electrons are moving, ionic conductor, ions are moving. And in an ionic conductor, fraction of current is carried by negative ions and remaining fraction of carried by the positive ions. Not only one ion, both ions carried the positive current, then we have to add them together to get the total current produced inside the ionic conductor. When you consider the ionic conductor, we have positive ions, it carries some positive current, I plus, we just assume it is I plus, and negative, again, it carries current minus. Then you can get the total current by adding them. Okay. Combination of both. Then we will see the electric current in a solution. Just imagine. Electric current is carried by ions in a solution. Let's assume we have a solution of copper sulfate. We have a solution of copper sulfate. Then what are the ions? You can see copper 2 plus and the sulfate. Then depending on the charge, you know copper 2 plus moves towards the negative terminal and the sulfate 2 minus moves towards the positive terminal. Hence, the current carries may be different in different solution. The flow of current in the electrolysis of copper sulfate is shown in this figure, and the current in the solution flow from where to where? B to A, and is equal to the external circuit. If you have external circuit, the current carries here from B to A is equal to the current given by the external circuit. In the solution, fraction of current I is carried by copper ions and the rest of ions carried by the sulfate ions. As I mentioned earlier, negative ions and the positive ions separately carry the current. Then copper ions move in the direction of B to A, and current carried by copper ion where to where? Copper ions where to where current carries?
B to A.
B to A. That is correct. Then the same direction, and it is positively charged in the same direction. If you consider the sulfate ions, what is happening there? Sulfate ions moves from A to
A to B.
B. The current carried by sulfate ion direction is opposite to the direction of movement. You know, if negative ions are moving from A to B, but the current is still moves from positive to negative, B to A. This is because sulfate ions are negatively charged, as in the case negatively charged electrons in the metal. Here, sulfate ions are negatively charged. Therefore, we can see it moves from A to B, and we can assume total current created inside this solution is equal to the external circuit current I, and we can express it with the combination of copper 2 plus and the sulfate 2 minus. Current created by the copper 2 plus and the current created by sulfate, you can add them together and you can get the total current inside the solution, and it is equal to the current supply from the external circuit. But you have to assume that current carried by the water is very small compared to the concentration of copper. If you have high concentration of copper, you know in water, if you have water, we have H plus and OH minus, it is very less, 10 to the power minus 7 M concentration. When you consider the solution of ions, it is very small. Therefore, we can assume that current created by OH minus and H plus, OH minus and H plus is negligible compared to the current created by copper and the sulfate ions. Got it? Okay. Then this is one assumption. If you need to write down assumption, you should know that one as it. Then activity 3, 1.4, question number 3. Rate flow of H plus is equal to this one. And the rate flow of sulfate ion is equal to this one. Then they are asking what is the electric current and fraction of current carried by each type of ion. Q is equal to NFZ. And also rate of flow of H plus Q is equal, I is equal to Q over delta T. What is given here? Rate of flow. What is given? Which one? මොකද්ද මෙතෙන්දි කතා කරන්නේ?
Q over delta T.
Q over delta T. What is that one?
Current.
Flow of ions.
Flow of ions. Okay. Then you can apply this one and you can use flow files. Then the rate flow is given. Then per second, how many moles? 2.9 10 to the
2.9.
power minus 5. Then
Minus
can
5.
you shuffle these two equations to get the current?
Yes, if
Yeah. Then can you try
and
it?
for
Q
the
is
H
equal
plus
to
2.9 into 10 to the power of minus 5
yeah.
into
Shall we
96.
rearrange use these two equations to get the relationship?
Of course, NF is Z by delta T. I is equal to
Oh, yeah. I is equal to
NF is Z by delta T.
instead of Q, you can write down NF Z. And you have delta T at the as a denominator. Delta T you need to get. Then rate flow. This is mole. And the second, what is this? This is this one, no? Once you see the unit, you can get an idea. How did it? Just looking at the equation, what is the unit here? Mole per second. If you consider N, it is moles. Delta T is second. Then it is similar to moles per second. Then you can use this flow of H plus. Instead of N over delta T, you can substitute 2.9 10 to the power minus 5. Then for the H plus, what is the Z value? If you consider the total current created by H plus, IH plus is equal to, then
2.9 into
I
10
am
to the
not
power of
writing
minus.
everything. Now you are in level 4. You should know how to substitute the value. This one multiplied by the Faraday constant with the unit, and the Z is what? Z is 1. For the sulfate ions, it is
2.
It's 2.
2. And this one is again changed. Then you can find out the current created by H plus and current created by sulfate ions separately. If I am writing everything, it is not good. Now you need to learn. Then total current, how to get?
We have to add those two.
Yeah, you have to add them together to get the total current. Then can you say fraction of current created by each type of ion? How to get a fraction? You have already learned under the phase how to get the fraction. Fraction of current created by H plus, how to get that one?
Current created
Fraction?
by H plus over total current.
Yeah, you have to get the current created by H plus and you need to divide it by the total current or current created by both H plus and sulfate ions. Got it? Fraction is total, no? The amount of current created by H plus to the total current. Okay, then I think you can do this easily. Just substitute the values. By substituting the values. Then we will move to the electric current density, J. It is given by J. The electric current flowing through a unit cross-section area placed perpendicular to the direction of current of a conductor. J is equal to Q over AT. You need to memorize this one as well. Current density J is equal to Q over AT. By the definition, charge per unit area unit cross-section area and per unit time. then, sorry, J is equal to this one, you have to know. Then if you convert it to the charge, it is Q over AT. The J is equal to current flowing through a unit cross-section area. J is equal to I over A. Current over cross-section area A. And if you convert I into Q, then J is equal to Q over AT. Then you do not need to memorize this one because you know what is the relationship between Q and I. What is I is equal to what? I is equal to
Q over T.
Q over T or Q over delta T. Yeah? It is okay. You can use T directly as well. Then Q over T. Then yes, substitute the value. Somehow Q is equal to IT. Q is equal to IT. Whatever which easy you can use. This one you have to use. You need to use this equation when for the analytical chemistry as well. Then it is easy to memorize this. Q is equal to IT because you have to apply it in number of. It means in analytical chemistry especially, you need to apply this equation several times to learn the electrochemistry. Therefore, it is better to memorize this one. Q is equal to IT. Then instead of Q, you can substitute the NFZ and you will end up with this one. Then you do not need to memorize everything, but the definition is more than enough. But for the exam, we are giving sometimes this relationship. Because some students can't memorize all the equation, then we are giving J is equal to MFZ over AT. Then how do you measure the charge passed through a solution? By coulometry, you can find out the charge passed through the solution. It means determine the charge passed through a pass by measuring only the mass of the metal deposit. For that one, we are using this coulometer. This one. Then you can see we have silver rod here and platinum disc. We call this one as silver coulometer. Then what is happening here? Once you pass the current, what happens? Just think you have this one. We supply energy. Then what can be happen there? Positive terminal, what happens? You have silver rod. What happens?
Dissociates.
It means what can be the equation? Silver
Ag into Ag plus.
Yeah, Ag. I am physical state and the Ag plus. Then next what happens at the minus means platinum dish. It means platinum dish connects to the negative terminal. This is what happens here. You have silver nitrate solution. Then what can be there? Happen there? You have a silver nitrate solution. Then negative terminal is there. What can we see here? What deposit?
Ag, silver.
Silver.
Deposit. Okay. Then in the solution, you have silver plus and it deposited on the platinum dish. This is how the silver coulometer works. Then cathode is reduction and silver rod. And you also know Q is equal to NFZ. You have already know that one. N is mass M over M. If you can measure the amount of silver deposited on the platinum dish, then you can get the charge. Okay. If you can measure the mass of deposit on the cathode, then you know if N is a constant, M is constant, then you can get the charge easily. In the activity 4, 1.6, we are asked in essential steps in using silver coulometer. I'll just introduce it because it is new thing. Now you know the circuit and I'll explain one by one. Then in this circuit, what we are going to measure? මොකක්ද measure කරන්න යන්නේ? What we are going to measure?
Mass
We are
of
going
silver
to
deposit.
mass of silver deposit where?
Platinum dish.
Platinum dish. Then what we have to do first? We have to wash the platinum dish thoroughly. Got it? Then dry it. And first we have to get the measurement of that one, and then you have to dry it. Then dry until the mass is constant. Why I am saying this? If you, even though you are in physics here, you
Remove
should
the
know how to-
impurities.
Sorry,
To remove impurities,
which kind of remove impurity? We wash it. Then water is
Water.
there. Then you need to dry it to remove the water. Why we don't know whether it is whether it remove everything or not, all the water droplets remove or not, we don't know. Therefore, what we have to do, we have to repeat it several times. For an example, we measure 30 minutes and see what is the weight. Again, 1 hour we wait. If the two weights are similar, that means it comes to the constant weight. Therefore, we have to dry it until it comes to the constant weight. Okay, dry until its mass is constant. Repeat the following 3 steps until the mass is constant. Heat in the oven, cool in the desiccator, and weigh. Then you will learn about the desiccator and everything later, but when you are going to the practicals, just get an idea. You have used already the desiccator in your level 3 practicals. Something heat, keep inside the desiccator and weigh it. Several times you can do it until get a constant weight. Then pour the silver nitrate solution into the platinum dish. We have to pour it. Then set up the electric current and perform the experiment. Then platinum this is in the cathode. And dismantle the circuit and pour the remaining silver nitrate out of the platinum dish. Wash the platinum dish. And be careful while you are washing. Don't rub it, just carefully wash it and get the weight. Dry it until it give the constant mass. Similar to that one, you have to wait until it gives the constant weight. Therefore, these are the steps you have to follow. Then looking at, I'll explain. First, you have to get the platinum dish, wash it, dry it, and pour the silver nitrate into this solution and connect to the negative terminal of the battery to the platinum dish and do the electrolysis. And after certain time, measure the weight of the platinum. You need to measure the weight of the platinum dish. Then you have to remove the silver nitrate and wash it carefully and dry it again and get the weight. That is the way how to do it practically. All the steps are there and we will upload the presentation. Then you can clarify everything. Then the activity number 5 is during an experiment which lasted for 1000 seconds, it deposited 10.78682 grams of silver in a silver coulometer. Calculate the charge and the average current passed to the coulometer during this experiment. Then mass is given. Then can anyone say how to find out the
Q is NFP over delta T.
Q is
Instead of N, we can use the M over capital M.
M
Mass over molar.
F? Is it?
Z
Then what is the
over
mass for this one is you have to
10.786.
then you have to divide it by the molecular mass of the atomic mass of the silver. We are talking about the atoms, atomic mass, silver only. Then F is Faraday constant with the unit, and Z is what?
1.
What is charge?
One.
1.
1.
Okay, thank you. Now, reaction is this one. For 1 mole, 1 atom of silver. You can find out the number of silver deposited in moles like this. Then you can multiply it by the. Then how to get the current? Current is equal to. Up to here it is okay. We already discussed. Then current is equal to what?
Divide by the
Q
time.
by delta T.
Q by delta T. Then it says it deposited silver for 1000 seconds.
1000
Therefore,
seconds.
you can use this Coulomb law and get the answer. This is very easy. Just memorize everything. You have already done it for your A-levels as well. Then we will move to the session 2 quickly. And I have to give the last session to Dr. Asel. That is the reason. Then the session 2 is based on the current flow gain a solution. And can anyone say what is resistance in physics? Resistance is measure of opposition to flow of electric current by a conductor. You know, if the resistance is high, what happens to the current?
It get low.
It is low. Then what is the relationship between current and the resistance?
In proportion.
V is equal IR. Then you know if the current resistance is high, then current is very low. This is the relationship between the current and the resistance. Then SI unit of the resistance, what is the value? These are A-levels, physics.
Ohm.
Ohm. If you use this equation, what is the value? 1 ohm is equal to what? Volt per ampere. Then both units are same. Then resistivity or specific resistance, what does it mean? What is the relationship between resistivity and the resistance? The resistance depends on the metal and the shape of it. If you get it, the shape depend resistance is equal to R is equal to rho L over A. You know, resistance depend on the part length and the cross-section area. Therefore, to get rid from that, we introduce the resistivity. Then R is equal to rho L over A. Then L is the length of the conductor and A is the cross-sectional area. Rho is the resistivity of the metal. The resistivity depends on the metal and the temperature. It depends on the metal and the temperature. Then rho is equal to R. If you rearrange this equation, rho is equal to R A over L. Then what is the unit for the resistivity? SI unit for the resistivity?
Ohm meter.
Ohm meter. Then the resistivity, raise hand, Vaibhute. Isuru? Resistivity measure of opposition of metal to flow of electric current through it. Resistivity is also same like the resistance. And how same way, how it opposition to the flow of electric current. Then In a metal, we are talking about the resistance and resistivity, but when we are going to the solutions, we are talking about the conductance and the conductivity. Can you say what is conductance and what is the relationship conductance and the resistance? Actually, conductance and conductivity is studying the electric flow properties of a metal, and it is much convenient to use conductivity, kappa, which is the measure of support by electron to the flow of electricity. Then it is the resistivity always opposite to the current flow, and then we are talking about the conductivity, which is support to flow of electricity actually. Then what is the relationship between G and the R? It is conductance is equal to the reciprocal of the resistance. Now what happens? If you consider getting the R relationship with the R, it is always limit the flow of electric current. But if you get the conductance, if you talk with that one, always, if you know the conductors, yeah, it conduct electricity easily. Then it is easy to work with conductance term. Therefore, and the current. Then in a solution, we usually use this one. And conductance, if the conductance is high, it support to flow of electricity or flow of current. And the kappa conductivity is equal to 1 over rho, reciprocal of conductivity. Then you know conductance is equal to reciprocal of resistance conductivity is equal to reciprocal of conductivity. Sorry, reciprocal of the resistivity. With the name conductance, resistance, conductivity, resistivity. Then kappa is equal to 1 over rho. Then you know rho is equal to what? R, AOL. Then you can substitute that value. And instead of 1 over R, you can say kappa is equal to GL over L. This is the relationship between conductivity and the conductance. Then the SI units for the conductance is Siemens. Then what can be the SI units for the conductivity? Conductance Siemens. Then conductivity?
Ohm
The
minus 1
relationship
meter
is-
minus 1.
Sorry? Siemens?
Ohm minus
No, I am saying conductance is Siemens. Yeah, you can give it from ohm as well. Conductance is Siemens. Siemens.
Siemens
Then,
per meter squared.
yeah, meter squared. This is meter. This is
meter minus.
meter minus. Then it is equal to Siemens per centimeter. Or 1 Siemens is equal to per ohm. Why? You know it. We can measure the R from ohm. Then G is equal to 1 over ohm is per ohm. Siemens is equal to 1 per ohm. Then if you have cube with the cross-section area 1 and the length L, what happens? Conductivity is equal to conductance. Why? If all are 1, 1, 1, then it is equal to conductivity is equal to conductance. Asela? Okay. Then Dr. Asela, are you there?
Dr. Kumudika, yeah. Keep
Then I'll
going.
give it to you. We can continue this later. It's okay.
Do you
Otherwise,
need more time? That's okay.
Then,
You can finish it. After that, I
okay.
will start.
Okay. Then what property characterizes the support to electric current flow by a solution? Can you use conductivity for this purpose? sorry, you can use this use conductivity for this purpose. If you want to find out the current in a solution, you can use the conductivity. And let's assume you are going to measure the conductivity using a conductivity cell. This is the picture given to you to show how to measure the conductivity. This is the conductivity meter cell. Once you comes to the practical, you can see that one. And you have to immerse it inside the solution where you need to measure the conductance. Then the resistance between A and B is the resistance of the cell of the solution trapped between the two platinum plates. Once you see, you can see you have two plates. This is A and this is B. Then what we are measuring the resistance here between A and B platinum plates and introduce the conductivity of the solution. In principle, we are using kappa is equal to 1 over rho is equal to 1 over R into L over A. What we explained, what I explained you earlier, what is the relationship between the resistance and the conductivity. And we are measuring the resistance here and convert it into the conductivity by using the conductivity meter. It is inside the machine, it is happening, then do not need to worry about that one. Then the activity 6 is show that J is equal to kappa E. What is J? What is J? I have already discussed.
Work
What is,
done.
sorry, J?
Current density.
Current density, kappa, conductivity, E,
Electric field.
electric field. Then electric field strength is introduced as E is equal to V over L. J is equal to I over A. Can you remember these two? I asked you to memorize. E is equal to V over L. J is equal to I over A. Then you need to substitute the values and show it. Then I'll explain. You do not, even as you do not have books, then you know V is equal to IR. Is it clear? From the physics you have already learned. Then V is I. Instead of R, you can say rho L over A. Then you can rearrange this equation. Then I'll show another step and rearrange it. You can keep I over A here and sorry, I over A. You can keep I over A here and it is equal to, we have V here. V, you can divide by L. You can get this L to here and divide it by L. Then V over L into this row you can get to other side as 1 over rho. I just rearrange it. This one over rho, V over L. This is given here. Then you can say 1 over rho, what is? 1 over rho, I over A, what is I over A? This is I over A. What is current density? 1 over rho. Rho means what? Rho?
Conductance.
R is what?
Resistivity. Rho.
Then rho is? This is resistance. Then rho?
Resistivity.
Resistivity. Then 1 over rho?
Conductivity.
Conductivity. That is correct. Then J is equal to conductivity V over L is electric field strength E. This is the way how to derive by starting from V is equal to IR. Just to rearrange the equation is more than enough to show this relationship. J is equal to kappa E. Then the activity 2.15, then just substitute the value and try. Okay, you have L value is 2.5 centimeter, cross-sectional area 3.5, and the conductivity is given. You need to find out the resistance. Then I think you can do it at home. It's just to find out just get the relationship and find the answer. Okay. And then let's see how to measure the conductivity inside the conductivity meter. Then this is the diagram relevant to the conductivity meter. And here you can see there are two resistors, R1 and R2. Here there are four things are there. Then this is resistor 1, resistor 2, resistor 1, resistor 2, and this is the variable resistance. And we vary this according to the resistance given by the solution. Not we, the instrument vary the variable resistor. Adjust the resistor. Detect, here we always detect current is there, how the detector is there to see the current is 0. We have a detector there to see the current is 0. Then both terms, the current is 0. It means this variable resistor adjust until this current comes to 0. Then don't worry about that one. Just to say what is happening inside there. And we have alternative current here, AC current. And we are not giving the DC current. If you supply the DC current, what happens? Electrolysis is happening. Therefore, we usually give the AC current when we are measuring the conductivity. And also you need to fully immerse the 2 platinum plates inside the solution. If they are not immersed fully, then the incorrect reading is given. And you know, when you need to immerse this into the solution, if you do not have an opening, can you immerse it? If you do not have an opening, you can't immerse it properly. Therefore, we can see an opening there in the conductivity cell. Then you can immerse it easily because it removes the air trap inside this one. Because it means you have a glass cell, and inside that you can see 2 cells, and this is the opening. This is and the material of this cover is glass. That is the reason we are keeping an opening here to remove the air trap inside while you are immersing it. And as I mentioned here, you have to immerse it fully. Then you can see 2 resistors, and you can say the relationship between RA or R2 is equal to so this relationship, you have 2 resistors, the ratio between R1 and R2 is equal to RA over R. R means the resistance given by our solution. This RA is the variable resistance and these two are fixed. Then we can find out the conductivity of the cell from the R1 over R2, from the R. Then conductance is equal to kappa A over L. It means 1 over Rx. Then instead of Rx, Rx means the solution resistance is equal to this. You can multiply. You can get the value in another. Then R1 over R2A. This R is equal to R1 over R2A. From this relationship, you can substitute the values and you can do the calculation. But we are not asking you to do the calculation, just measuring the conductance and the relationship more than enough. We are not asking anything related to this physics part. Don't worry about that one. Just to show you what is happening here is in this slide. Okay, then thank you very much and have a nice day after finishing the next lecture. Thank you.
Thank you, madam.